Hey Space Cats, I'm Dr. Maggie Lou. Welcome back to my channel. Imagine a world where reaching space was as easy as taking an elevator ride. That's the idea behind space elevators, the revolutionary technology that could change the way that we access space. In this video, we're going to talk about just that. So let's begin. So what exactly is a space elevator? Space elevators, also known as orbital elevators, are a concept for a technological structure designed to stretch from the surface of the Earth to outer space. They are considered one of the most promising and futuristic technological advancements for space exploration and access. Now, a space elevator is not going to be one of those conventional elevators that you're probably familiar with. A tower into space is not going to work. It's just going to be too heavy that it would collapse under its own weight. The basic idea of the space elevator is instead a long cable that extends from the surface of the Earth to a stationary point in space. At the end of the cable would be some counterweight, and the structure would be anchored to the Earth's surface and held in place by the centrifugal force created by the Earth's rotation. Recall that the centrifugal force is the force that you're probably most familiar with from that time when you were a child on the playground and spinning on those merry-go-round rides. The faster it spins, the stronger you feel the force pulling you away from the center. Now that's the centrifugal force. It's not really a force as per se because there's not actually anything creating the force. There's no object creating the force. Check out my other video on why gravity might also not be a real force if you haven't already. I'll put a link up here. In any case, the centrifugal force pushes the counterweight acting against the centripetal force of gravity that pulls the counterweight towards Earth. The counterweight thus not only remains in space, but climbers, little platforms, could then travel along this cable to reach low Earth orbit, where you could launch spacecraft, satellites, and even bring astronauts into space. The climbers could then come back down to Earth and pick up more payloads, and this process could be repeated time and time again. Currently, launching a spacecraft into space requires a huge amount of fuel, which is both expensive and environmentally harmful. It costs between $10,000 and $20,000 to send 1 kilogram of weight into space. But a space elevator could use much less energy. It could cost as little as $200 per kilogram. This would reduce the cost of launching payloads into space by a significant amount, making it more affordable for commercial and governmental organizations to access space in the future. In addition to the cost savings, there are huge risks associated with rocket launches. These include equipment failure, human error that would be greatly reduced with the use of space elevators. The climbers would also eliminate the need for astronauts to undergo physical and psychological strain of space launches, making it safer for astronauts to reach low Earth orbit. This space transport system could remove the need for expensive and dangerous rocket launches once and for all. Okay, so now that we know what a space elevator is and why we need one, what's the plan in getting one built? In terms of location, space elevators can be built anywhere as long as the location meets certain requirements for supporting that structure. However, the most ideal location for building a space elevator would of course be by the equator, as this would take the most advantage of Earth's rotation and allow for the greatest stability of the structure. The cable would have to be long enough to reach geostationary orbit, such that it orbits the Earth at the same rate that the Earth rotates. This ensures that the top of the elevator will always remain in the same part of the sky as seen by a person on the ground. This means that the cable has to be at least about 36,000 kilometers long. That's almost the equatorial circumference of the Earth. Unfortunately, one of the main challenges is the development of a cable or ribbon that is strong enough to withstand the forces exerted on it, especially with the elevator traveling up and down. Currently, no material exists on Earth that is both strong enough to support the weight of the cable and the payloads while simultaneously not being too heavy. However, the same concept is similarly applicable to celestial bodies with gravity much weaker than ours. So think the moon or Mars. In these places, the cable wouldn't have to be so strong, and already existing materials, such as Kevlar, are strong and light enough that could be practical to tether a space elevator. Another challenge is the risk of being hit by space debris. So you have satellites and spacecraft and meteorites, which could all collide with the cable and cause damage. For this reason, it was suggested that a ribbon be used instead of an actual cable, and this would be able to better withstand impacts by meteoroids due to its shape. But additionally, the large surface area could make it easier for climbers to climb with a simple roller mechanism. Now, as a payload is lifted up a space elevator, it not only gains altitude, but also angular momentum, in other words, horizontal speed. The angular momentum is taken from the Earth's rotation. This is the Coriolis force. The top of the cable is at a higher distance from the Earth, so it's traveling a larger distance around the Earth than the bottom of the cable. Therefore, the climber is accelerated horizontally as it ascends, and the cable will lean away from the direction of the rotation of the Earth. This also means that with each ascent of the space elevator, it would slow the spin of the Earth down. But don't worry, the amount of change would be tiny, a fraction of a second per day. And when you're descending payloads, the spin would increase again. So our Earth spin is safe. Technically, such technology has already been proven to be feasible. Since 2009, a research team at Shizuoka University have been testing the feasibility of a miniature tether mechanism linking pairs of nanosatellites. Their latest mission was just launched in 2021, and they still have more of these dubbed STARS missions, which stands for Space Tethered Autonomous Robotic Satellite missions, to push the boundaries on longer cables and higher payloads. However, a real space elevator on Earth would also have the problem of being slow. At the speed of a very fast car or train at about 190 miles per hour, it would still take 5 days to climb to geosynchronous orbit. As much as it would be so cool to live in a world where getting to space is as easy as taking an elevator, overall it's likely that space elevators will not become a reality for many years to come. It may even take decades or centuries before they're fully operational. However, the potential benefits of space elevators make them highly promising technology, and continued research and development in this field may bring us closer to their invention in the future. Current targets are actually 2050, so not that far away. That's all for this week's video. If you enjoyed it, please don't forget to leave me a like, share, and subscribe.